Alright, Andre. Part 2. We'll start with alarmables. So here's the manager, and then it has alarm IDs. I did 5. Just 5, yeah. And so here's the full header file for the alarmable manager, and then the header file for the alarmables. You got registration, deregistration. You can get how much time remaining, add time, subtract time, cancel it. And it has, you have to do this registration data struct. It has the commands for each alarm, and then a delete reference for constant time, and then the registration state. And here is the class diagram. I couldn't get it to show the association for these. But yeah, so basically it has a multi-map, like we talked about, like a timeline. And so then it so we'll go with, registration. Well, we'll go to the multi-map, because then it can, it depends on the time. And so it could go in order of which alarm goes off next. And so it just checks the first alarm. If it goes off, then it's going to call that alarm, trigger alarm. And so registration is the same, and it's just based on which alarm. It goes by alarm, the struct, and then you process the alarms. Just grow switch statement. It has to be. No, it doesn't have to be. That's how it is in mine. Yeah. And so then we'll go to the keyboard. Inputables. So we got the keyboard event manager, unordered map, and then a single key event manager for each key registered, and then the input event types, enums, which is key press, key release. The inputables, let's deal with the registration, deregistration, and then call the functions, key pressed, key released. And so I did registration with a map because there's just so many combinations of keys. And so you have the input register. It creates a new input registration data, which has the registration command, deregistration command, registration state, and then the delete reference for both press and release. And so here is the map. So keyboard event manager holds the single key events, and then when the input submits the command, it goes to the same to the keyboard event manager, sees if it has that key. If it doesn't, it creates it. If it does, then it will just automatically register that key. and processing the key events. It goes through each one and checks what state it's in, and then checks if that frame is the same as the other one. I'm thinking we could change this. Instead of this if, we could do a strategy pattern. So that's some for further optimization there. So the collision system. It's so fun. I love working with templates. Okay. So with the collision manager. Yeah. So this sets the collision pairs and then does it with the commands. So here are the commands. That's the base, and then here's the collision test pair command, and then the self one. And here's the collision volume B sphere. And then this is for the delete command. So the collision manager deletes them. And then each collidable has a collidable, each register collidable has a collidable group. And it's a singleton. And then this is where it registers and deregisters. Collidable. And then here's the class system. The class diagram. So then the collidables. This is where you register for the collision, and so it creates the registration commands that are templated, and then so then here's where you set the registration state. Yeah, and that's everything. And then like I said, collision manager cleans up through the delete commands. Alright. And then so the game object. I did it where it inherits from all the ables. Inputable, collidable, alarmable, drawable, updatable. And so this is where the overrides come for all of them, and then it has the scene entry and or submit entry and submit exit. And then so this allows, so when you submit it, it goes through the current scene and you submit the entry command. So we'll do that. Better see the CPP. So then it will go and then do the game object of exit and entry, basically. And to prevent doubling up on the exit, it goes to the registration state. So even if it's called multiple times, it'll only do it once it's registered, and so it's registered, right? And then you say exit, and it gets set to deregistered. And if another exit is called, it just won't call this at all. It'll test it though. And so I used it in the bullet factory and a tank factory that I have set up. And so, yeah. Alright. Sprites. So I had the game sprite. I showed the image manager. Here's the .h. Yeah, class diagram. Not that interesting, I don't think. It's basically just a wrapper. And then you put the render in the draw 2D, and create a sprite manager. But yeah, you just put a string in there, and then it'll grab it, the image. And so then it deals with it and sets the default center, scale, angle, rotation, and then here are all the functions. And then the user sets everything and then calls update sprite. And then so the render will render to the current camera, 2D camera manager. And I showed the draw thing in the draw manager, in the drawable manager. Alright, visualizer. I'm trying to get into 30 minutes, but I don't think it's gonna happen. Okay. Visualizer. And then I have the commands, and then the factory. Okay. So the visualizer, it's a singleton, and where you render and you submit the B-sphere, which works with the command pattern. And then here is the class diagram. And so the command is basically that's the base. And so it returns with the factory. And so you can use it over and over again. Done through the command pattern, only one game object is used.